Right, in this video we're going to pick right up from where we left off in part 1 of the DMA 40 review. This is part 2. We're going to pick up on problem 16. Make sure you have looked at part 1 for problems 1 through 15, and we'll finish it up in this video. So problem 16, the instructions say to translate and solve each word problem, show your work. Alright, so for a wedding, the reception cost will be $5,000 plus $50 per guest. The bride and groom have budgeted $12,000 for the reception. And the question we want to answer, how many guests can the bride and groom invite to the reception? Now, since this module revolves all around equations, I want you to set up an equation, I want you to solve the equation, and then answer the question. However, I do want to show you a slightly different approach, but I'm going to compare it to how we actually solve this problem using an equation. Since they have $12,000 budgeted, and it's going to cost them $5,000 right off the bat before they invite any guest. So $12,000, they got to pay $5,000 right off the bat. That leaves them with $7,000. And again, the reason why I'm subtracting that, their budget is $12,000. They got to pay $5,000 right off the bat, so that leaves them with $7,000. And then, since it's going to cost $50 per guest, we can divide $7,000 by 50. And if you do $7,000 divided by 50, that leaves you with 140. That is the answer to the problem. They can invite 140 guests. However, I want you to use an equation. Let's take the equation approach to this problem. So instead of us doing this scratch work right here, here's how I really want you to do it. Let's let G equal the number of guests. And let's think about how much they're going to have to spend. Right off the bat, they're going to have to pay $5,000 plus $50 for every guest they invite. And we're going to set this equal to 12,000. Let me show you what this equation is actually showing. This is how much they can spend. This is showing the money that they're going to spend. They're going to pay $5,000 plus $50 for every guest they invite. For example, if they were to invite one guest, 5,000 plus 50 times 1, that would just be $5,050. If they were to invite 2 guests, 3 guests, 4 guests, 5 guests, it can keep on going, but we want to figure out what is G equal to make this over here on this side of the equation equal to $12,000, which is their budget. So now that we have an equation set up, we can solve this equation by subtracting 5,000 from both sides. Bring down what you have left. The 5,000s cancel. We have 50G is equal to $7,000. Maybe you're already noticing this looks familiar. Notice up here, we took the $12,000, subtract $5,000 to get $7,000. That's exactly what we have there. To finish this equation off, we divide both sides by 50 to get G by itself. The 50s cancel, and you have G equals, well, 7,000 divided by 50. We did it right here. We get 140. This is the approach I want you to take on the module exam. I want to see you set up that equation, and I want to see you solve the equation. But notice we're doing the same moves over here without doing algebra. But again, I'm after the equation approach when you go to solve these problems. Therefore, the solution to this problem is going to be they can invite 140 guests to their reception. Now, suppose you did take this approach over here. I mean, I'm going to be honest with you. There's nothing wrong with that because you're doing the arithmetic. The thing is, again, we want to translate this, and let's translate it into an equation, and let's solve the equation. That's what we spent this whole module doing, solving equations. So, that's number 16. Number 17, the sums of the angles of a triangle are, it should be R, 180. So there's a triangle. The measure of the first angle is twice the measure of the second angle. The measure of the third angle is 80 more than the measure of the second angle. So notice, anytime we do a word problem like this, I mentioned this in class, you got to start somewhere. Start with a variable. It says the measure of the first angle is twice the measure of the second angle. So notice that word second angle is popping up there. Notice the word second angle pops up again in this sentence. The measure of the third angle is 80 more than the second angle. So we'll call this our second angle, and let's start by giving it a value of x. This is our second angle. All right, our first angle down here. Quite honest, to be quite honest, I don't care where you put the first and second angle, but I just decided to put the second angle there. This is the first angle, and notice the first angle is twice the measure of the second angle. Well, we call the second angle x. The first angle is twice that. So how about 2x for the first angle? That's how we get that. Since we call the second angle x, the first angle is twice the second angle, so we have 2x. And now for our third angle, the measure of the third angle is 80 more than the second. 80 more than the measure of the second angle. The second angle is x, and since the third angle is 80 more, it's going to be x plus 80. This means 80 more than the second angle, since again we call the second angle x. And now we want to find the measure of each angle. So based on this sentence right here, the sum of the angles of a triangle is 180. Let's add up all these angles so we can take the first angle of 2x plus the second angle, which is just x, plus the third angle, which is x plus 80. Notice we're adding all three of these angles together that we have in this triangle, and let's set this equation equal to 180 because the sum of all the angles of a triangle is 180. That's where that 180 comes from. Let's combine like terms. 2x plus 1x plus 1x, that's 2, 3, 4x. Bring down your plus 80, and this is equal to 180. And solving this equation, we can get or subtract the 80 from both sides. The 80s cancel out. We have 4x is equal to 100, and then divide both sides by 4. That gives you x is equal to 25. So back to your picture. We said, and look, the reason I'm going back to the picture, the question says to find the measure of each angle. So we need to know all three of these. So the first angle, we said it was 2x. So first angle equals 2x. And now since we have found what x is equal to 25, therefore we multiply 2 times 25. We're plugging 25 into that x right there. That gives us an angle of 50 degrees. The second angle was simply equal to x. Well, we just solved the equation. X is equal to 25. So therefore, the second angle is 25 degrees. And then our third angle is equal to x plus 80. And again, we want to plug 25, since x is equal to 25, plug 25 into x. So you have 25 plus 80, and 25 plus 80 is equal to 105. So therefore, the third angle is 105 degrees. So some things you can do real quick to check your work. You can add all three of these angles back together. If you take 105 plus 25 plus 50, you do get 180. And then notice, if you go back and read the problem real quick, it says the first angle is twice the measure of the second. This first angle of 50 is twice that of the second. Since this is 25, that's going to be 50. That's 2 times as big. And then it says this third angle, the measure of the third angle is 80 more than the second. Well, 80 more than 25, that's exactly what we did right here. That is 105. So those are your three measurements right there. If you chose to write that as a complete sentence, that will be fine, but I'm fine with you just labeling it like this. The first angle equals 50, the second angle equals 25, and the third angle equals 105. Don't forget your degrees though. 50 degrees, 25 degrees, 105 degrees. All right, question 18. A mixture problem involving a solution. How many quarts of a 10% antifreeze solution must be mixed with 16 quarts of 40% antifreeze solution to make a 30% solution? All right, so I have a table set up for you here. And notice we have some type of solution, we have some other type of solution, and we need a certain solution. The solutions that we have a 10% antifreeze solution. We also have a 40% antifreeze solution, and we need to make a 30% antifreeze solution. How about the amounts? Well, how many quarts of 10%? We don't know how much. We had the 10% solution, but we don't know the amount that we need. So we're going to call that X. We got to give it a variable if we don't know what it is. Do we know the amount of 40%? Well, the problem says how many quarts of 10% antifreeze solution should be mixed with 16 quarts of 40%. So we do know that's 16 quarts. I'm just going to put 16 down there. Therefore, our total amount, we don't know exactly what the total amount is going to be, but it's going to be the sum of these two numbers. So we can write X plus 16. You add down to get that amount. Some amount of quarts of 10% plus 16 quarts of the 40% is going to be X plus 16. That's all we can write right there. And then we convert our solutions to decimals. So therefore 10% is going to be 0.10, 40% is going to be 0.40, and 30% is going to be 0.30. And then this last column here, this is where I told you in class that you want to find the product. Multiply across. So multiply these two together. X times 0.10 is 0.10x. 16 times 0.40. 16 times 0.40, that's going to be 6.4. And then this one right here, when we multiply, we have to do the distributive property. So it's going to be 0.30 times these two terms. So notice I put those in parentheses. And then in class, when we cover this type of problem, we are adding these two solutions. Imagine you got a bottle of 10% solution, you have a bottle of 40% solution. You want to add these two solutions together. You want to add these two solutions together to get a mixture that equals this amount. You want to add these two together to equal a 30% solution, but that's what we have here. This is where your equation comes from. You add these two solutions together to get a solution that is equal to this right here. That's how we set up our equation. So therefore we have 0.10x plus 6.4, set it equal to this solution down here that we have. So it's going to be 0.30. Let me make some more room. I'll tell you what, I'll bring it down here. 0.30 times x plus 16. Now some of you may have went ahead and distributed here, which is fine. I'll go ahead and do it right now. I'm going to leave the left hand side alone and distribute here. 0.30 times x is 0.30x. 0.30 times 16. 0.30 times 16 is going to be 4.8. And now let's solve this equation for x. Therefore, what we have to do, I like to move the smaller one to the bigger one. Let's subtract 0.10x from both sides. Therefore, when we do that, let's bring down what we have left. The 0.10x is canceled over here. You're left with 6.4 is equal to 0.30x minus 0.1x. It's going to be 0.20 or just 0.2. You can leave the 0 off. I could have left the 0 off up here, up here, up here. You could have left those zeros off. It's just fine. And then bring down what you have left. You have plus 4.8. And let's solve this equation for x. Subtract 4.8 from both sides. And 6.4 minus 4.8, when you do that, you should get 1.6. This is equal to 0.2x, and to solve for x, divide by 0.2 on both sides, and when you do that, you should get a total of 8. 8 is equal to x, and again, we do have x left over here because the 0.2's cancel out. So let's go back to our problem. The question said, how many quarts of a 10% solution? Well, if you look at the table that you filled out, that's exactly what we have right here. We're trying to find the amount of the 10% solution. Well, we need 8, but we need what? We need 8 quarts of the 10% solution. So make sure you write a complete sentence. We need 8 quarts of the 10% solution. Since x was equal to 8, therefore, and we are answering the question because it says how many quarts of the 10% solution. You're trying to find that number right there. And we need 8 quarts. Just a little question out on the side, how many quarts are you going to have in all when you combine the 10% solution and the 40% solution? Well, we just found this answer to be 8. If we have 8 quarts of this and 16 quarts of this, the total will be 24 quarts in all that make a 30% solution. But the only thing we had to find was that x there. But again, it's all about this idea over here, forming your equations and adding these two to equal that amount right there. And that's how we solved that. All right, the next problem. A car leaves a vacation spot traveling at 50 miles per hour. Half an hour later, their friends leave the spot in a second car traveling at 60 miles per hour. Let's think about what's going on. One car leaves traveling at 50. Half an hour later, their friends leave the spot. Same spot, let's say they're heading in the same direction. That's how we have to do this file. That's how we have to approach this problem. Since they left later, but yet they're traveling faster, eventually they will catch up with their friends. So car number 1. Let's consider car number 1 being the first car that leaves. Let's fill this information in. The car number 1, its rate is 50 miles per hour. Now, we don't know how long it's going to take. So let's just say car number 1 travels for some time t. So how do we fill in this distance? Well, recall the formula, rate times time is equal to distance. 50 times t, well, we can't do anything else but write 50t. All right, so car 1 is going to travel this distance 50t. Car number 2, when the car number 2 leaves, they travel at 60. However, they don't travel for the same amount of time that car 1 travels. Remember, they left half an hour later, so they're going to travel 30 minutes less. Now, depending on if you want to use minutes or whatever, I'm going to do t minus 0.5. This is going to be represented by hours. T sometime minus half an hour. Had you did t minus 30, that would have been in terms of minutes. T minus 30, because half an hour is 30 minutes. But let's use t minus 0.5 since we did say half an hour. So t minus 0.5. And again, how do you find a distance? You take the rate and multiply times the time to equal the distance. So therefore our rate here is 60, and we multiply it by t minus 0.5. And again, I'm setting up the distributive property because this is 1 term times 2 terms. Now the idea is, if car number 1 leaves, I'm just going to try to get you to visualize this. Car number 1 leaves, it's already gone a certain distance before car 2 even takes off. So when car 2 takes off, car number 1 is still moving along, but eventually, since car 2 is going faster, it's going to catch up. And when car 2 catches up with car 1, they have actually traveled the same distance. They traveled the same distance. So in this particular problem, if we're talking about catching up, these two distances, we want to set them equal to each other. But you have to be careful how you read the problem. That's what we want to do for this one, but the problems can vary. So set these two distances equal to each other. 50t, that's the first one, is equal to 60 times t minus 0.5. And again, the reason why we set them equal is because car 1 left, and when car 2 eventually catches up to it, that is going to be when both cars have traveled the same distance, even though they have been traveling for different amounts of time. But by us setting up this chart, filling in the information, we can solve this equation. I'll make this a little bit bigger. So on the left-hand side, I'm going to leave it alone. On the right-hand side, let's distribute. 60 times t is 60t. 60 times a negative 0.5, that will give you negative 30, or subtract 30. Because really all we're doing there is taking half of 60, and let's not forget our sign. Now, in this case, if you did move the smaller to the bigger, that can lead to some problems. Let's move the t over here, though. It'll be fine either way you do it. I'm going to subtract 60t from both sides. 50t minus 60t is negative 10t. This is equal to, the 60t's cancel. All we have left over here is 30. And now we divide by negative 10. We get t is equal to a positive 3. So the question did ask us to find how long will it take the second car to catch up. It will take 3 hours for the car to catch up, or the second car. Now, let me just go ahead and hit on something here. Maybe you were working this problem out and you got to this step right here, 50t is equal to 60t minus 30. And if you're doing the idea of moving the smaller one to the bigger one, maybe you did subtract the 50t from both sides. Well, 50t minus 50t, you have to show something over here. And the reason why is because there's nothing else left. 50t minus 50t, even though it cancels, that's actually equal to 0. Over here on this side, you got 60t minus 50t, that is 10t. Bring down your minus 30. And now when you solve this equation, you will still get the same answer. Add the 30 to both sides. You have 30 is equal to 10t. And then when we divide by 10, you do get 3 is equal to t. Same exact answer, just the algebra is a little bit different, but it's still correct. So our final answer, it will take 3 hours for the second car to catch up. Let's look back at this problem. Suppose I did ask you to find the distance. How far did these cars travel? Well, we found the answer to be t equals 3. Our answer was 3 hours. Well, if they traveled at 50 miles per hour for 3 hours, that would be 50 times 3. That car traveled 150 miles. Car 1 traveled 150 miles because they traveled at 50 miles per hour for 3 hours. Now, this car down here going 60 miles per hour, though it traveled faster, it traveled a lesser or a shorter amount of time. Well, since t was equal to 3, actually this is number here, t minus 0.5, 3 minus 0.5 is equal to 2.5. So car number 2 traveled at 60 miles per hour for 2.5 hours. And if you do 60 times 2.5, that's also equal to 150. That's going back to us setting these two distances equal to each other. Even though they traveled for different amount of times, they both went the same distance because that second car is catching up to the first car. And the reason why it caught up is because it is going faster. Now, last but not least, we have a few inequalities to solve, graph, and then we need to write them in interval notation. In class, I've mentioned this, solving an inequality is a lot like solving an equation. This is the left side of the inequality, this is the right side of the inequality. Just like if it was an equation, you'd have the left side of the equation and the right side of the equation. So let's add 20 to both sides of the inequality. Cancel the 20s out, bring down what you have left. Negative 3x is less than or equal to 21. However, there is one little difference, and not one, there's several differences. Right here, when we divide by this negative 3, whenever you multiply or divide by a negative number, you need to flip that inequality. Therefore, this becomes x is greater than or equal to negative 7. So that's part of your solution. So we have this, we've solved it, Now we need to graph it, and we need to write it in interval notation. Since this inequality is greater than or equal to, we put a solid dot on -7, and then we shade to the right. Shade to the right. And I'm just going to shade it like this. So it goes forever in that direction. Now, before we talk about interval notation, I do want you to check your work. Let's take a number that's in this shaded region. I like checking 0 as long as it's in the shaded region. Let's plug 0 in up here. -3 times 0 is 0. 0 minus 20 is -20. And -20 is less than or equal to 1. So that definitely satisfies the shading. It satisfies the inequality. That's showing that we shaded in the right direction. And the reason why we shaded in the right direction is because we want numbers that are greater than or equal to -7. Some hints I also mentioned in class: if your variable is on the left-hand side, the inequality will point in the direction that you need to shade. Had you not flipped this thing, you would have been shading this way, and had you plugged a number in, it would not have worked. For example, -10. If you forgot to flip this inequality and you shaded to the left, -10 does not satisfy this thing. And let's see why. -3 times -10, that's a positive 30. Positive 30 minus 20 is 10. 10 is not less than or equal to 1. So again, remember to flip that inequality. And if you're skimming through this video or whatever, I hope that catches your attention. You need to flip that inequality. Now, interval notation. For interval notation, you want to put the smallest number first. The smallest number we can have is -7. And it goes on forever to the right. Forever and ever and ever and ever and ever to the right. Therefore, it goes on to positive infinity. And since this is an equal to, we put a bracket around the -7, and we always put a parentheses around the 8. There is your interval notation. So that's how you do that. I did mention this too. Sometimes you may be taught, instead of putting a closed dot, you might just be taught to put a bracket, which matches that bracket there. But I'll talk about an open symbol too. Bracket or closed symbol, I'll accept either one, should you have decided to put a close bracket. So it could look something like this. Close bracket going that way. All right, next problem. So we got some decimals. Let's solve it. The left-hand side, we can't do anything with that right now. I'm going to bring it down. 0.5n minus 0.3 is less than. We need to distribute. So 0.2 times 2n is 0.4n. And then 0.2 times 1, remember anything times 1 is itself. So therefore we got plus 0.2. Let's work on getting the variable on one side. I'm going to move the n over here, and the n is smaller here. This is the smaller one, and we're going to move it to the bigger one. But again, it's a good idea to think about trying to get that n on this side anyway. Maybe because at the end, that little cheat I showed you, the inequality will point in the direction that you need to shade. So let's subtract that 0.4 from both sides. 0.5n minus 0.4n is 0.1n. Bring down what you have left. Minus 0.3 is less than. Those cancel, bringing down the 0.2. Now let's work on getting n by itself. Therefore we add 0.3 to both sides. So bringing everything down, we got 0.1n. The 0.3's cancel here. We have less than, and then 0.2 plus 0.3 is 0.5. And now lastly, let's divide by 0.1 to get the n by itself. There's no need to flip here since we're not dividing by a negative number. So our solution looks like this. N is less than 0.5 divided by 0.1 is 5. So there's part of your solution. Let's graph it. Open circle or a parentheses here. Either one I'll accept. We're going to put an open circle on 5. Or you could have put a parentheses opening in that direction, because notice we want numbers that are less than 5. These numbers are less than 5. And then that little hint, as long as your variable is written on the left, this inequality will point in the direction that you want to shade. So we do want to shade to the left. And we go forever to the left. And again, like I said, open circle is fine, or a parentheses, but not a bracket. And now let's do our interval notation real quick. Interval notation, you always want to write the smaller number first. 5 is definitely not the smallest number. It's actually the biggest one. The smallest number is actually negative infinity, the farthest number to the left. So we go from negative infinity all the way up to 5. But since we can't equal 5, we want to put a parentheses around the 5. And we always put parentheses around our infinities or negative infinities. So there is our interval notation. There's our solution, and there's our graph. Everything all in one. Okay. Now let's check our work here. Let's make sure this makes some sense. I like to plug a number in. Now we got decimals to plug in, so that's going to be a little pain, but it'll be all right. Let's plug in 0. Since 0 is in the shaded region, it should work. Plugging in 0, 0.5 times 0 is 0, minus 0.3, we get negative 0.3 over here. Plugging in 0 right here, 2 times 0 is 0, plus 1 is 1. 1 times 0.2 is 0.2. Think about those two answers that we just got there. We got negative 0.3 on this side when we plugged in 0. We got 0.2 on this side when we plugged in 0. And now notice the inequality does satisfy this. Negative 0.3 is less than 0.2. And I just plugged in a random number that was in the shaded region. Whereas if you had plugged in something over here, this inequality would have not made sense. So valuable to check your work and just make sure you shade it in the right direction. On to 22. Another inequality, solving this one. Let's make sure we distribute. 2 times 8 is 16. 2 times w is 2w. And make sure you keep that plus since it's a positive. And this is greater than 22. Working on getting w by itself, subtract 16 from both sides. Therefore, we have 2w is greater than 22 minus 16. That is going to be 6. Dividing by 2 on both sides, we get w is greater than 3. So, going to the graph, we want to put an open circle or a left parentheses or parentheses that opens to the right. And the reason why this is opening to the right is because we want to shade to the right. The reason for that is because you want numbers that are greater than 3. All these numbers that are shaded are greater than 3. So therefore, if you were to use a parentheses, you would want to make it open to the right, which is also called a left parentheses. But let's check our work real quick. Let's make sure one of these numbers satisfies our inequality. Let's plug in 5. 8 plus 5 is 13. 13 times 2 is 26. 26 is greater than 22. Let me ask you a question. Does 0 work? It's not in the shaded regions, so it should not work. Let's see if it does. 8 plus 0 is 8. 8 times 2 is 16. And as you can see, 16 is not greater than 22. So therefore, that's why 0 wasn't shaded, because it does not satisfy this inequality. Now let's not forget our interval notation. We want to write our smallest number down first. The smallest number we have on our graph is 3. The biggest number, it goes on forever to infinity. And we want to put parentheses around both of these. We always put parentheses around our infinities or negative infinities. And since it couldn't be equal to this open circle, since it couldn't be equal to 3, we put a parentheses around it. That's interval notation. All right, problem 23. I'm going to work this one out by moving the smaller number to the bigger number. Just for the heck of it. You need to get used to it. Get comfortable with it. Moving the smaller one to the bigger one, yes, it is putting the variable on the right-hand side. That is okay. So the 6y's cancel, bring down what you have left. You have 13 is greater than y plus 6y is 7y plus 6. Solving this equation for y, subtracting 6 from both sides. And I said solving this equation, but it's solving this inequality, by the way. 13 minus 6 is 7. 7 is greater than 7y. Dividing by 7 to get y by itself, we get 1 is greater than y. Now, I'm going to leave it like that. If you left your answer like that, I'm totally fine with it. You want to put an open circle on 1, but let's make sure we read this inequality correctly. We want 1 to be bigger than our numbers. We want 1 to be bigger than our numbers. Well, for 1 to be bigger than some numbers, we need to shade to the left. And you might say, well, hey, I thought it's going to point in the direction that we need to shade. That was only if you had the variable written first. So if we had the variable written first, we need to write that inequality like that. Because notice here the alligator is opening its mouth up to 1, and the alligator is still opening its mouth up to 1. So either one of these solutions are fine, but by having that variable written first, this will point in the direction we need to shade. We read this as y, some numbers that are less than 1. All of these numbers are less than 1. Interval notation, our smallest number is negative infinity since we're going forever to the left. And we go all the way up to a positive 1, but we want to use parentheses around both of them since we don't have an equal to symbol. Again, you could have did a parentheses on that 1. And just to show you what that looks like, it could have been something like this. You could have put a parentheses like that instead of an open circle. Either way, I'll accept it. So we have our solution, we have our graph, and this here is our interval notation. All right, and I think that is all. I thought we had a few more, but I guess not. So there's your entire review. This is part 2. Make sure you've watched part 1, and that is it for this video. Hope it helped.